that you do need, call it 1B. So you do need to set the corrected exposure time if you have it before you do this, at least before you set air mass, because then you would go in here and where I have X time, you would put in CX time. But as far as I remember, the command would be something like image, then you would say CX time, then you would say for perhaps X time plus 0.02, something like that, then add plus. You can also say ver plus, then it would verbose, and then you know it's verify, and then it would tell you that I'm not going to present it because I'm not going to add it, but that would add this image, this header information to your header. The other command is imhead, and I'm going to do that because we're going to look at I see 1613. Let's take the V fits. Then I say L plus, and then I pipe it into something called page. Let's see if it wants. No, it wouldn't. Oh, how dare it! And let's take a look. Why? Ah, yeah, of course. I need to have a 1. That's more like it. So this is the image that I took. You can say that the IRAF format is actually from NOAO. Yeah, that's how that was then made it. So you have the X time here. I could have also used exposure if I wanted to. I think it's here. The set temp, so it tells me what the temperature of the detector was, minus 25. As you can see, or not see, but as you probably know, that professional telescopes, they have something like minus 100 or something degrees. Readout mode 12 Hz, that's not important. The filter type is V, we're going to use that. Filter name. Image time, it's light frame, we know that. Side latitude and longitude, you can use that actually as keywords, I think, if you want, but as you can see, I've used those. The thing is that you need to convert this into common numbers instead of these hour numbers here. Then there's the Julian date, the focal length, aperture diameter, aperture area, all those things, blah 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 blah. My name, yes, that's me. Yeah, so on, so on and so forth. Let's go down a little bit. So you can notice that the plate scale here, we're not going to use that extensively. We are actually not going to use it at all, but you could use it if you want to. The time odds, that's one of the keywords that we needed. You could also use UT, it's the same. The air mass, and that is the effective air mass because I've already changed it. And yeah, you can say the RA, the declination, all those things. One of the things you can notice is that you can actually use the full width half medium from here instead of doing this. That's up to you. And let's see, the zero magnitude, I don't think that's very reliable, but I haven't tested it. And then there's a lot of when MaximDL do a plate scale, a plate solve with pinpoint, it gets a lot of notifications here. But one of the things that is very interesting is let's there. So I have added gain and R noise, read noise, and gain to my fits header. I would suggest that you do the same. And then when you run the set air mass command or the task, you automatically get the middle exposure time. And that is very reliable, and that is very important because that will give you real information about that is the time you need to use, and you're going to see that. The gain and the read noise, you can choose not to add them. It's not mandatory, but I think it's a good idea. And also, if you want to see, you can see that the WCS pinpoint here, the match 56 stars from the gray blah 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 catalog, and the residual was 0.48 arc seconds. That's pretty good. Alright, but this is the fit setter. If you haven't seen one of these before, then I suggest you take a look at them and study them, because they give a lot of interesting information about your setup and what you have in your images and all those neat things. But the UT middle here, that is pretty important, as you can see. If we're going to use it henceforth. Let me just see what I did. So I used this cal, then I used this star here. It's sort of a joker, so it takes anything that's called cal with something in the middle and has fits as its last name, and then it will give you the effective air mass and the UT middle, the mid observational keyword. That's pretty important. I'm just going to say save and quit. So we have done with this part here. Let's move on. So we need to set the DAOFIND parameters. So we need to know the point spread function, full width, half medium. I'm not sure why I call it P. It should be an F, full width, half medium. You can use ImXAM-A. I'm going to show you how to do that. So let's do like this, for example. I'm not going to get the fit set. I'm just going to exploit that I have put in. So I'm going to say display display this image, and then you put a 1. As you can see here, IRAF has frames, so we have frame 1. We can get frame 2, we can get frame 3, we can blah blah blah, get all the frames that your memory can hold and IRAF can handle. And that is what you set here. I could set 200, I could set 16, but I'm just going to choose to do 1 and say display. So here we have an image in the V filter for IC 1613. Now, one of the things that annoys me, really, perhaps it can do it, but I haven't figured out how to get it to do it yet. But IRAF can't handle WCS, World Coordinate System. Let me just give you an example. If I take a new frame and open the exact same image, Astro, let's just make this a little tad bigger. OVBO, reference, IC16, the date, and it was the V1, so V1. Let's open it, and you can see, let's just say scale, set scale. It's not so pretty, but as you can see, we have world coordinate systems up here. Let's change it to degrees. You can see when I move around on the my viewport here, you can see that the coordinate system changes, and this has more profound consequences as well. For example, if I do this, I get this little circle here, and then I try to scale it so it's roughly the size of the star, and then move it around a little bit. Let's say things like that, something like that, and then I can open this circle parameter here, so I can say that this star is roughly 0.3 arc minutes or 18.71 arc seconds in diameter. Now this is a rough estimate, right? But roughly, yeah. So I can actually get information about how much this star is the size of the star. I could do this in another way. I could take the image size and say it's 11.42, and then I could take over here somewhere we had the fit scale somewhere. I think it was before, further up. I hope you can remember it, otherwise then just go back and look at it again. But it told us how much one pixel is defined or is referenced to in arcseconds. And this is what IRAF DS9 can do automatically when we have world coordinate system. Now it says FK5. It's because I've chosen degrees. I could put it per sexamal. No, it still says it, but nevertheless. And you can take it in ecliptic, and you can take FK4. You can do all sorts of neat things that you want to do. But nevertheless, we're going to use FK5. But we're also going to delete the frame. Alright, so now we're back, and this is what this star here. If I did the exact same thing, I would only get the size of the star in pixels. But that it's not very important right now. But it just annoys me that IRAF can handle world coordinate system data as far as I know. Nevertheless, now we have opened the image here, and we can choose to say imexam. The task is exactly called imexamine, but as long as you put in enough letters that it is that it can't be distinguished from another task, IRAF can figure out what to do. So now we have imexamine started. If you're usually over here when you type, obviously, and if you try to do anything now, you would just type in things in here. So you need to click at somewhere where you don't click on anything, and then you can go around here. Let's find a nice little star like this one. And remember, you can use the arrow keys to move around. You have two options here. You can say A, then you get a lot of information. You get the column, you get the line, you get the coordinates. Not in WCS, it's in image coordinates. You get the R, I think that, I'm not sure what that is, residual, something like that. Then you get the magnitude, the flux, you get the sky background, you get the peak value at that star, 6000 ADUs, you get an error on that, and then you get the position angle, and then you get a beta, an enclosed, a Moffat, and a direct. And I would usually go for the last one, the direct, but it's up to you. These are the full width half medium, enclosed, Moffat, and direct. I'm not sure what the beta is. One other option, you can type R instead, then you get a plot like this, and again you get somewhat of the same information. You get the R, you get the magnitude, you get the flux, you get the sky, blah 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 blah, and the last number here, 2.11, that's the full width half medium of that particular star. But you can also use the full width half medium from the sky fitting, the plate solving calculation in here. It will, to my best knowledge, give you correct information. Now you have done that, you can say Q for quit, you get your command line, and you can close this. So this is basically how you get the numbers that you need here in the checklist. The gain and the read noise, you need a find gain. It is a package that I have downloaded. As you can see, it's in the user catalog. I'm not sure where I actually found it, but what it does is that you give it 2 flat frames, 2 bias frames, and then you select a box where you want the calculation to be done. You can say what kind of statistical measure you want. You can say the bin width of the histogram, and what it gives you out in return, I'm just going to say save and quit because I don't have it, is the read noise and the gain. And you need that, as you can see. I've said find gain. And the data max, I found that from the sensor data sheet. I'm not going to use it actually, but this is to say Well, the sensor I have can handle 60,000 ADUs, but I want it in electrons. No, sorry, it can handle 6,000 electrons, but I want it in ADUs, so I multiply it with the gain, and then I subtract 5,000 because I want to be on the safe side, and then I get 48,580 ADUs, but I just used 48,000, so I changed that to a lower number, but that doesn't matter really. This is in order for you to make sure that you don't go over the sensor's linearity. And in order to find out what linearity for a sensor is, I had to make another video to explain that. But basically, you can say that the linearity of a sensor defines to what extent you can trust the photometry you get from it. So you need all these numbers. So let's go ahead and look at DAOFIND. And I'm going to start at FOD, just to be sure. No, sorry, DAOFIND. Yep. And then I'm going to say EPAR DAOFIND. So here's a lot of parameters. Now, for IRAF, not PyRAF, but IRAF, you won't have these boxes here, and that's what neat about PyRAF, is that in IRAF you would need to type in :E and then, for example, data pass or find pass. In here you can just click and then you get it. But in DAOFIND you need to define the files, the output, just set it to default, then you get image name plus COOQ and then a number. Now DAOFIND will increment your number, so if you run it once you'll get Q1, you run it again you'll get Q2 and Q3 and so on and so forth, and then when you run FOD it will automatically select the highest number because it assumes that the last DAOFIND you ran was the one that you were happy about, and I I must say I actually don't find that so strange. But a little neat trick when you're going to set up these files here. You need to set up what's going on in here, obviously. But let's just say save and quit, and then EPAR FOD instead. Now when you open FOD, DAOFIND FOD, you don't need to concentrate on anything in here other than these 4 boxes here in PyRAF. This is only for PyRAF. What you can do also is you can say EPAR find pass instead. You should get the same box. You can do that if you want to. And you can also say LPAR FOD, and then you can see you get data pass, center pass, fitsky pass, and FOD pass, and then you can just say, well, I want to do like let's say FOD pass. We don't have that open yet. Copy and then say EPAR and then put it in, and then you get the same box that I showed you before. The only advantage of adding the parameters in FOD, in photometry task instead of DAOFIND, is that you can some of these parameters are shared. You can see that both FOD and DAOFIND share the data pass and the center pass, I think, or it's some of these. But what you can do is that you can say, well, I'm going to change, let's take data pass. So what you need to know is the scale. I think in just about any cases, you can set this at 1. I would argue that. Then you need to set the full width half medium point spread function. We haven't worked with real point spread function yet. You need to fit those actually, but more or less we're going to put in the numbers that we got. I put in 2.15 Perhaps I should put in 2.85, something like that. It should be somewhere around where you get the full width half medium of your stars. Features are positive, yes, don't change that. The sigma value here, the standard deviation in counts, you can also get that. Let's just go save and quit. Didn't show you that, but let's open imexam and again, and then you can say, I think it's is it H? No, sorry, yeah, now I did it. Let's just take a look. M. Alright, so let's go in here, press Q, and then we are in here. Let's just say M. You can see the standard deviation here is your background, but you have to do it in a place where there are no stars, and preferably also no noise. That is pretty hard to do here on my image, but nevertheless that's the thing you need to do. Then you can see how wide a box it uses, blah blah blah, 25 pixels, and you can do the mean value. No, actually, just yeah, I think the mean is your sky. Yeah, the mean is your sky. But nevertheless, it is, to be honest, not really that important. I think you need to set it. I have just sorry, EPA font. I have just experimented with it. I set it to something roughly like the sky background, perhaps the sky background times 2, something like that. The minimum good value is something like 4 or 5 times negative, I think 3 times your what's it called, your read noise. So in this case my read noise is 14, and so I think it's minus 2 or 3 times, something like that. And again, in order to ensure that I don't overdo on the linearity, I didn't actually use 48,000 as my data max. I used it 30,000. Then you set the noise model, it should be Poisson, the fish. Then you can set the readout noise image keyword. I've put it in. Only use those if you have put in added read noise and gain as your in your header. But you also need to put in the numbers, so I'm not sure why you can actually do that. Nevertheless, 14.008 and 0.893. Exposure is the exp time. If you have the corrected one, use the cexp time or whatever you call it. Air mass is okay, filter is okay, time ops time. Yeah, that's the problem. It should be UT middle. Yeah. And eye time, exposure, air mass, blah blah blah. Yeah, that's okay. Save and quit. I think it's because let's just see. Just going to check something. Font, EPA, DAOFIND. It's still alright, but I think it's because I use AppFont instead of DAOFIND. EPA font doesn't matter. To find it, so I didn't put in the correct one. Fit sky pass. If you have let's take FOT pass. So if you have an observation with a seeing or a full width half medium of 4 pixels or less than that, something like that, you should probably use apertures somewhere between 12 and 15 for your photometry. If you have 4 pixels, I think the recommendation is you should use probably 15. So because I have 2, 3 something in full width half medium or FWHM, I've used an aperture of 13. So basically what this tells IRAF is how much should it where should it, on the image, when it has found the center of the star, where should it calculate the photometry? So it takes 13 in scale units out. The zero magnitude, I've used 25, just use that. Then we need to set the fit sky pass. Alright, so the parameters that you need to concentrate on in here is the annulus. So the fit sky fitting calculation algorithm should be mode. The annulus, it should be 18. That's the inner radius of sky annulus in scale units. So it's basically, if you have, it tells IRAF where it should start the sky fitting annulus. So I would say whatever number you choose in the photometry annulus plus 5. So in this case I've used 13, so I've used 18 here, and then the width of the sky annulus 5 should be okay. You shouldn't put in any user value, you shouldn't put any maximum number of iterations, it's okay. You should actually leave this as it is and then just say save and quit. Center pass, centering algorithm should be centroid. The C box here should be something like 2 times your FWHM, so roughly 6 I have chosen to use. I could use more precise number, but I think 6 is okay. I'm just going to check my phone. I got a very important message from my wife. Alright, and as far as I remember, you shouldn't change anything else in here as well. So let's just say save and quit, because we're not going to do photometry yet. We're going to say par DAOFIND. Now what I have done is I've created an input image, and sorry, but I have to go to the bathroom right now. Be right back in just a second.